Good morning, friends. Welcome back to science class on the chapter light. Just recall what we had studied in the previous section. In the previous section, we studied image formation by concave mirror. Okay, so first we placed that object at infinite distance. See, first we kept that object at infinite distance. So then we got the image at principal focus. Then size of the image is it is very small, means highly diminished, and it is point sized. Then what about nature? The nature of the light is it is realigned inverted. Why? Because we got that image on the screen. Next, we kept the object behind the then we kept the object behind the C. Okay, so at that time we got the image between C and F. Then the size is it is small, means it is diminished. Okay, then nature of the image is realigned inverted. Next, we kept that object at the center of curvature. Okay, so we got the image at the center of curvature only. Then at that time, size of the image is same. It means that image size is equal to object size. Okay. Then nature of the image is real and inverted. Next, next we kept the object between C and F, that is center of curvature and principal focus. Then we got the image that is behind the C. Okay, so at that time size of the image is it is which is enlarged. Okay, means here in this case size of the image is greater than the size of the object. Okay, then nature of the image is real and inverted. Why? Because we got the image on the screen. Next, we kept the object at F. Okay, we kept the object at F. Then we got the image at infinite distance. Okay, so here in this case, so consider one is parallel to principal axis. After reflection, it passes through. After reflection, it passes through principal focus. Okay, so consider one more ray. It passes to a pole of the mirror. Yes. So now consider. So now these two rays are parallel to each other. Okay. Parallel to each other. So this side also and behind the mirror also. Okay. So here we get the image at the infinite distance. Here the rays never meet. Why? Because they are parallel to each other, and here all the rays are very close to each other. Okay. So that's why we'll get the image at the infinite distance. Then what about size? Size is it is highly enlarged. Okay. Next, then what is the nature of the image? The nature of the image is real and inverted. So next, we kept the object between F and P. Okay, we kept the object between F and P. So control is parallel to principal axis. After reflection, it passes through like this. Then here. Okay. See here. So now position of the object is between F and P. Then where is the position of the image? The position of the image is behind the mirror. Okay. Position of the image is behind the mirror, and size of the image is enlarged because size of the image is greater than the size of the object. Then what is the nature? So here you won't get real image because these two reflected rays are okay, these two reflected rays are they never meet. Okay, because when you increase the lines, then the distance between these two lines is keep on increasing. Okay, so that's why after reflection the rays they never meet. So that's why we won't get a real image. Okay, But here, if you exchange these two reflected rays, both the reflected rays are meeting at this point. At this point, we will get the image, but that image is virtual image. For example, if you take just imagine this is a plane mirror. If you pass the rays of light, the rays, they won't come this side, right? If you come and see, there's nothing. Okay, so means this image, it doesn't exist. It doesn't exist. Okay, so here the nature of the image is virtual and erect. It is erect means it is straight. See, just observe here. In the except this case, the remaining case we got inverted image. Okay, like this. If you keep the candle like this, then we will get image like this. Okay. Always the real images are inverted. Okay, but virtual images are erect. Okay. Next, in this case, the images are, when you keep the object between F and P. In this case, the images are formed by a concave mirror, virtual and erect. Except this one, so when you keep the object at F, or when you keep the object between C and F, or at C or P behind C, or at infinity. In all the cases, we'll get the real and inverted image. Okay. Yes, sir. Next, move to uses of concave mirrors. And one more thing, for example, I will give you one concave mirror. Okay, so I will give you one concave mirror. How do you find out its the focal length? Okay, so I give you one concave mirror. How do you find out the focal length of that mirror? Because here we don't know center of curvature. Okay, we don't know where is the principal, but we know the whole of the mirror, right? Yes. How do you find out the principal focus? Sorry, not principal, focal length. What is focal length? Focal length means it is the distance between principal focus to the pole of the mirror. How do you find the focal length of the focal length of the concave mirror? See, yesterday you have studied, when you keep the object at infinite distance, so after reflection, where the rays are meeting? Correct? When you keep the object at infinite distance, after reflection, all the rays are meet at one point, right? Okay. So what do you call that point? That point is principal focus. Okay. When the object is at the infinite distance, after reflection, all the rays will meet at one point. Okay. Yesterday you have studied, when you keep the object at infinite, you will get the image at the principal focus only. Now, if all the rays are converges here, so then we can call this point as the principal focus, right? Okay. Next, see, if this is the principal focus, then take the distance from F to P. Okay. So then you'll come to know focal length. Okay. So this is the easiest method to so we can calculate. We can find out focal length of any mirror. Sorry, any mirror. So next we move to uses of concave mirrors. Next, use of concave. Okay. See, now from using concave mirror we can get real and inverted image. So sometimes image is bigger and sometimes image is smaller than the object. Then what are the uses of concave mirrors? See, first one, we use these mirrors in solar furnaces. Solar furnaces, okay. Next, suppose see, I will give you sheet of paper. Okay, is it possible? Is it possible to burn that paper using a concave mirror? Just think, I will give you a sheet of paper. Okay, I think you have played with the magnifying lens and you have burned some papers. Okay, so that is lens. We discussed it. Now, using a concave mirror, is it possible to burn the paper? Yes. Why? Because see, now when you face this concave mirror to sun, sun is at the infinite distance. Okay, when you keep that paper at the principal focus, when you keep that paper at the principal focus, at this point, all the sun rays are after reflection, all the sun rays are meet at this point. So, which means at this point, heat concentration increases. So when you keep the paper at F, so you can burn the paper. Okay. So due to this one, so we can use concave mirrors to produce a large amount of heat. Okay. So this is the first application of concave mirror. Okay. In the solar furnaces, we use concave mirrors to produce a large amount of heat. Okay. Next, second one we use in bike headlights. Okay, bike headlights or torch lights. Torch lights. Okay, second one we use concave mirrors in bike headlights or torch lights. See, just imagine. See this here. So now I will keep one bulb here. See, just imagine. Okay, so these are rays of bulb. Light moves in a 360 angle, right? So that's why. See, if you use this mirror, this bulb in your bike headlights, see, you will get only this much amount of light. But what about this side? I think it is waste, right? See, if you keep one concave mirror here, you studied when you pass a ray of light through principal focus after reflection, it is parallel to principal axis. Okay, so here if you keep that bulb at F, if you keep that bulb if you keep that bulb at F, see these rays, they will strike the concave mirror. Okay, because these rays are coming from F, principal focus. After reflection, once again these rays are parallel to principal axis. Okay, so now here to get a powerful parallel beam of light, we use concave mirrors in bike headlights and torch lights. Okay, why? Because here we will keep that bulb at the principal focus. Okay, then these rays, okay, without wasting these rays, they will strike the concave mirror here. After reflection, they will parallel to these rays or parallel to principal axis. So then we can get the parallel beam of light. Okay, so that's why we use concave mirrors in bike headlights or torch lights. Okay. Next, uh, next we use these mirrors in shaving mirrors. Okay, so here we use shaving mirror. When you keep the object between C and F, when you keep the object between yeah, when you keep the object between C and F, at that time you will get the image at you will get the image behind C. Okay, so here the size of the image is greater than the size of the object. Okay, so we use concave mirrors in the shading mirrors because to see the large face of the image. Okay, to see the large face of the image. Why? Because when you keep the object between C and F, okay, then we will get the bigger image, correct? So in this case size of the image is greater than the size of the object, so that's why to see the large image of the face we use shaving mirrors. Okay, next fourth one. So concave mirrors are used by doctors, dentists. Okay, okay, so it is used by dentists. Okay, why? Because just to see the large image of the teeth, otherwise it will be difficult for them, okay, to do some what is operation or whatever it is. Okay, just to see the large image of the teeth, so that's why dentists they will use concave mirrors. Here also same, when you keep the object between C and F, we'll get the bigger image, right? That image is enlarged than the object. Here size of the image is greater than the size of the object to see the large image of the tail. So that's why we can use concave mirrors are used by dentists. Okay, so these are the applications of the concave mirrors. In your exam they will ask more reasons why concave mirrors are used by dentists, or why we use in shaving mirrors, or why we use in bike headlights. Okay, and you should know the reason. Okay, so next to move to image formation by a convex mirror. Okay, till now we have studied image formation by concave mirrors and uses of concave mirrors. So next to move to image formation by convex mirror. Image formation by convex mirror. Okay, image formation by convex mirror. Image convex mirror. Okay, so that reflecting surface is curved outwards, which is away from the center of curvature, which not faces the center of curvature. Okay, if the reflecting surface is curved inwards, then we call it as a concave mirror. If the reflecting surface is curved outwards, then we call it as convex mirror. Convex mirror. Okay, for example, just imagine you are passing up so many rays of light. Okay, so after reflection, all the rays are diverges like this. Why? Because here the rays are never met. Sorry, all the rays are diverges. Okay, now study one by one. So here also let us make one table First, position of the object. Next, position of the image. Next, position of the object, position of the image, then size of the image, then nature of the image, C. Okay. So now the reflecting surface is curved outwards. So now consider first keep the object at infinite distance. Okay. Position of the object at infinity. Okay. So when the object is infinite, the rays are parallel to each other. Okay. So now here to show the image formation, we will consider only two rays. Why? Because if where the two rays meet, at that point the remaining rays will meet. Okay. So now these two rays are parallel to principal axis. You know, after reflection, all the rays are passes through. Now these two rays are parallel to principal axis. After reflection, these rays are passes through principal focus. But here the principal focus this side. Okay, clear? How to show? You know, yesterday we have studied day before yesterday we have studied, right? Ray diagrams. Ray diagrams in convex mirrors. Okay, so now here also same. Just to draw the normal from the center of curvature. So now use your protector, keep the baseline over normal and measure the angle of incidence. Okay, so then it reflects like this. So now this is the reflected. Just observe here. See, if you extend this line. Okay, so now this ray it passes through principal focus. Okay, so now consider this one, and one more here. Don't forget to put the arrow marks. Okay, now so now here also draw the normal from the center of curvature. Okay, so after reflection, it passes through. It reflects like if you extend this line, this ray reflected ray also. It passes through principal focus. See, observe here. Now these two reflected rays are virtually meeting at F. Okay, reflected rays are virtually meeting at F. So now position of the object at infinity, position of the image. Now these two rays are, see, they are not meeting, right? So that's why, but these two rays are virtually meeting at F. Then the position of the image is at F or principal focus. Position of the image at F. Okay. Next, what about size of the image? See, just observe here. It is both the rays are meeting here, right? We get the image here, which means it is highly diminished. Okay, highly diminished and point size. Highly diminished and point size. Next, what about nature? Okay, see, you know, if just when this is a convex mirror, if you pass rays of light, okay, the rays then on this side, right? Okay, so that's the nature of the image is and erect, which means that image doesn't exist. Virtual and erect. Okay. So now this is the object at infinite, position of the object at infinite distance, then position of the image at the principal focus, then the size of the image is highly diminished and point size, then nature of the image is virtual and erect. Okay. Next, if you place a screen over here or anywhere, you won't get real image. So that's why nature of the image is virtual and erect. Next, see in a concave mirrors, first you kept the object at infinite distance, then behind C, then at the C between C and F, at F, then between F and P. But here you can't keep like that. Okay, what you did in concave mirror. But here, why? Because the principal focus and center of curvature that is behind the mirrors. But if you keep any object here, you won't get any kind of reflection because this is a reflecting surface. This side is it. Okay, so that's why here only two positions. One is at infinite distance. Then second one is between infinity and pole of the mirror. Okay, between infinity and pole of the mirror, you can keep here or here or here anywhere. Okay, so now position of the object between infinity and pole of the mirror. So I will keep here object. I will keep the object here. So now once again consider one ray is parallel to principal axis. Okay. So one ray is parallel to principal axis. You know, after reflection, that ray virtually it passes through principal focus. Next, consider one more ray which passes to pole of the mirror. So after reflection, it reflects in this direction. So now this ray also it virtually will move like here. See, now these two reflected rays are virtually meeting between F and P. Okay, so then we get the image here. Okay, now so position of the image between the infinite and pole of the mirror. Then position of the object between infinity and pole of the mirror. Then what is the position of the image? Position of the image is behind the mirror. Okay. Behind the mirror. What about size of the image? Just compare this size and this one. So this one is small, right? So that's why size of the image is diminished. Size of the image is diminished. Next, what is the nature of the image? The nature of the, because you won't get the real image on the screen. Okay, because which is behind the mirror. If you keep a screen here or here or here and here, you won't get the real image. But we are getting virtual image, which means which doesn't exist. Okay, so that's why the nature of the image is virtual and erect. Virtual and erect. Okay, see, if you keep the object at this position here or here or here or here or here anywhere, okay, you'll get the image between pole of the mirror and principal focus. Or if the object at infinite distance, then always you'll get the image at the F. Okay, so you know, here we studied only two cases, right? So we can strictly say that the images are formed by formed by concave. The images are formed by concave mirrors are always virtual and erect. You won't get real images using convex mirrors. Okay, but the images are formed by a concave mirror, both virtual and real. Okay, see that depends where you will keep the object. When you keep the object between F and P in concave mirror, then you will get the virtual image. Okay, but here in convex mirror, the images are formed by convex mirror are always virtual and erect. You won't get real images using convex mirrors. Okay. Yes. So next move to the uses of convex mirrors. And observe here in convex mirror, size of the image which is not greater than size of the object. See, in first case we have studied it is highly diminished. In the second case, it is diminished. If you keep here or here or here, you will get a diminished image only, means small image only. Okay. In convex mirrors, the size of the image is never greater than size of the object. Always we will get diminished and erect image, and it is virtual. So next motto, uses of convex mirrors. Uses of convex mirrors. Okay. See here the images are found where convex mirror virtual and erect, and the images are diminishing. Where do then what are the uses of convex mirrors? Just think. Okay, see, first one we use convex mirrors in the automobiles. Okay, see we use this convex mirror as a rear view mirror in automobiles. Why? Because see, the images are formed by a convex mirror always diminished. Okay, the size of the image is not greater than the size of the object, and which covers wider field of view, which covers wider area. Okay, to facilitate for driver to facilitate safe driving. Okay, so that's why we use convex mirrors. As rear view mirror in automobiles. Okay, next. We use these mirrors in at sharp turns. Sharp turns. Okay. For example, just imagine if the road is U shape. Okay. See. And this, see here, in this case, here we will keep the convex mirror here, because, for example, just imagine you are traveling here. Okay, you should know, right? This said which vehicle is coming, whether it is a small or big, because we have to give space to that vehicle. Okay, so you should know. You should know which vehicle is coming from this side. So that's why we use at this point convex mirrors. Why? Because this convex mirrors which covers wider area. Okay, so that's the reason we use convex mirrors in at sharp turns. Okay, so these are the uses of convex mirrors. See, till now you have studied the image formation and the image formation in concave and convex mirror. So here, if you say sometimes we'll keep the object at the infinite distance, then you will know the position of the image. Or if you keep the object at C, then you will get the image at C only. Or when you keep the object at F, you will get the image at infinite distance. Okay. Suppose if it is in a concave mirror, sorry, convex mirror, if you keep the object at infinity, you will get the image at F only. If you keep the object between infinity and the pole of the mirror, then you will get the image between pole of the mirror and principal focus. Okay. So now, is it possible to find the position of the object or position of the image without doing diagrams? Okay. Yes, it is. If you know the for example, if you know the focal length of the mirror, or if you know the object distance, then we can find the position of the image. For that, we have one formula, that is 1 by F is equals to 1 by U plus 1 by V. Okay, so we call this formula as mirror formula. Okay, so here small f represents the focal length of the mirror, and U represents the object distance, and V represents the image distance. Here, if you know the focal length and the object distance of that mirror, then we can find the image position of the image. Or if you know the focal length of the mirror and if you know the position of the image, then we can find the position of the object or where that object is placed. Okay. Or if you know both the object distance and position of the object and position of the image, then you can calculate the focal length of the mirror. Okay. We call this is the mirror formula. Here F represents focal length and U represents object distance, and V represents image distance. Okay. So next move to sign conventions for reflection by spherical mirrors. So this is very important. Okay, while solving problems, you have to follow sign convention rule. Otherwise, you can't do any problems. Okay. See, just imagine this is a concave mirror. Concave mirror, pole of the mirror F, and this is C. Okay. So now just imagine I will keep the object here. So now while solving problems, you can't take it directly. For example, in your problem they will give the object is placed at 25 centimeter from the mirror, like that. At that time, directly you can't take the U is equals to 25, or in problem they will give the the image is formed at 15 centimeter from the mirror. At that time, you can't take V is equals to 15 centimeter. Okay, here you have to follow sign convention. Okay, sign convention rule. So first one, see here we will take U, V, and according to your Cartesian coordinate system, that is XY graph. See, we call this is first quadrant, second quadrant, third quadrant, fourth quadrant. Okay, here these all values are positive values, and these are positive values. These are negative values. These are negative y values. Okay. So now just imagine here we have to make one assumption. Okay, we will take always. Okay, in optics. Optics means it is a study of. It is a branch of physics which deals with the study about light. Okay. Always we will take that object distance. Okay, that is U as negative values. Okay, because which is always will take it as left side of the mirror. Left side of the mirror. Now see, this is the origin, right? This is the origin. Now take this point, pole of the mirror as origin. Okay. So now always we will take that object distance. It is in negative. So which means that is negative axis. Okay, negative axis. While writing object distance always you should write in negative values. Suppose there will be what the object is placed at a 25 degree, 25 centimeter. At that time, you should write u is equals to minus 25. Why? Because the object is placed, always will place that object left side of the mirror. Left side of the mirror means which that object which lies in this axis, that is minus. Okay, so that's why while writing object distance, always we should write u value in negative. Okay, next, this is the object distance. U always we should take in negative. Next, suppose we will get the image here, here. Okay, so so here the image is formed left side of the mirror, right? So now this is the origin and this is the origin. Left side means what? Here, right? This axis. Okay. So now you should compare this height with respect to this y axis. Okay. So now here, while writing, you should take v in negative. Okay. Suppose the object, suppose they mention what the image is real and it is formed 25 centimeter from the mirror. At that time, you should write v is equal to minus 15 centimeter. Okay. But here, see, sometimes when you keep the object between f and p, at that time we will get the image here, right? Okay. So in this case, we should take v value, image distance in positive. Why? Because this side means this axis, this positive x-axis, that is right side of the mirror. Okay, right side of the mirror. Here, all these values are positive, so that's why here you should take v as positive. Okay, if see, when this is possible, when the image is virtual and erect. Okay, see, we got all the real images left side of the mirror, right? That is this side. Okay. So next, what about focal length? Okay, we'll take a focal length in negative. Always for concave mirror, we should take focal length in negative value. Suppose there will be a problem, focal length of the concave mirror is say 10 centimeter. At that time, we should take focal length is equals to minus 10 centimeter. Clear? And one more thing, here we should take u value always negative. Why? Because it is left side of the mirror. Left side of the mirror means this axis, minus x axis. Here all the values are in negative only. Maybe sometimes maybe v is positive or v is negative. In a problem, if they mention the image is real, okay, if the image is real, then you should take v values in negative. Then if they mention the image is virtual, at that time you should take v as positive. But you should take for concave mirror, you should take focal length in negative values and object distance in negative values. Okay, so this is the sign convention in concave mirror. So next we go to sign convention in convex lens. Convex mirror. See, here we will take this and just compare with your Cartesian coordinate system. This is pole of the mirror and this is the principal focus. So now this is convex mirror. Convex mirror. The reflecting surface is curved outwards. Okay. So now always in concave or convex, always will keep the object at the left side of the mirrors. So now here also we should take u values in negative. Okay. Next, see, we will get the image. See, here we will get the image at f or between p and f. Here on the right, you won't get the images left side of the mirror in convex mirror. Why? Because in convex mirror the images are formed by a convex mirror always virtual and erect. We won't get the real image. So that's why we will get the image at f or between p and f. Here you should get v value always positive. Why? Because this is the origin it lies here, right? Means this is a positive x-axis. Positive x-axis. So in convex mirror, while writing v values, we should write it positive. Okay. Next, is it possible to get the v values? V values is negative in a convex mirror. In concave mirror, sometimes we get the values in the negative, or sometimes we will get in positive. That depends whether the image is a real or virtual. But for convex mirror, you won't get the real image. You get only virtual image. So that's why for convex mirror, always you should get v values in positive. Always you should get v values as in positive. Next, what about focal length? So here you should take focal length of the convex mirror as positive. Okay. For concave mirror, you should take f as positive, and here sorry, for concave mirror f as negative, and for convex mirror you should take that f as negative. Okay. So this is the sign convention. Yeah. So I will stop here. Tomorrow I will continue the class.